Hello and welcome to this episode of AI GovCast. I'm Sylvia Oakland and I'm live here at the AI+Expo in Washington, D.C. And I'm really grateful and fortunate to be joined by Eric Pierce from the Savannah River National Laboratory. Eric, thank you so much for joining us.
Thanks for having me.
Yeah. Why don't we go ahead and just jump right in, as we were talking before we hit record, about the ALTEMIS mission and what that all looks like for the environmental management side of the labs.
Yeah, so ALTEMIS is a tool set that we've brought together that leverages a number of different sensor modalities, ranging from pressure transducers to geophysical measurements of the subsurface to measuring things like pH, salinity, or salt concentration in the groundwater. And we harness all of that information in real time to predict how groundwater plumes move in the subsurface. The reason why that's really important is because DOEM, in this case, the Savannah River Site, has something on the order of about 2,000 groundwater wells. And they spend quite a bit of money sampling those groundwater wells. And the traditional way that occurs is they take a sample from each individual well, they send that sample off to an analytical laboratory. The analytical laboratory spends times characterizing that sample and then sending back data, all right? We have to do that 4 times a year for 2,000 wells. So that's a lot of man hours, a lot of effort.
How long does that typically take, from soup to nuts with that process?
Oh, man. So for any one well, I could say that that's usually somewhere on the order of a couple of hours a day, right?
Okay.
All right. So it's a lot of effort.
Yeah.
And then on the back end of that, those analytical runs at an analytical lab also takes quite a bit of man hours, all right? And then once you collect that information, the scientists have to analyze that information to tell us something about the system. So again, that's additional man hours as well, right? Well, AI and the ALTEMIS mission allows us to just simply do that much, much faster, all right? We go from taking a sample once a quarter or 4 times a year to simply collecting one sample, one verification sample to use to demonstrate that our modeling tool with ALTEMIS is really predicting the way the plume is behaving in the subsurface. And that allows us to reduce all of those man hours, something on the order of about 70%. That's pretty important for the country. The reason is because EM represents the second largest liability for the nation, next to Medicare and Social Security, all right? And our jobs at the National Lab is to harness technologies, new tools, new advancements, generate new advancements for the purposes of allowing this particular mission to happen much more cost-effective for the nation, while still providing the same level of value to the states as they try to understand how these subsurface contaminant plumes migrate.
Yeah, and I think we hear a lot about AI helping with efficiency gains, it's helping with productivity gains, but all of that is built on years and years of data. And I was watching a simulation from your colleague Tom's presentation, and it was so fascinating to watch that data play out in a real-time a simulation. But he also talked about the data readiness level, and I loved how he had it. It was like a spectrum almost of ready to, I don't know if we're going to be ready at all. And so I was wondering if you could talk a little bit more about kind of what that data readiness, what those levels look like, maybe where you're at right now. And we're almost halfway through 2026. So where do you expect to see yourself at the end of this year?
Yeah, great question. The Office of Environmental Management has existed since the early 80s, all right? So you can think there are many, many, many decades of data collected in many, many, many different ways, right, to where we are today. And we've seen this evolution of sensors, sensor technology. Today we're measuring things in our houses that we've never measured before, right, in very different ways. And similarly, we've seen that in kind of this environmental monitoring approach. So what that means is there's different data types that are at different AI readiness levels, all right? So that's why Tom referred to data readiness levels. In today's EM environment, in the case of ALTEMIS, right, we're collecting data right now in one footprint of the Savannah River Site that is providing data in real time that is already AI ready, and we've implemented those AI tools. And that's probably for the entire EM mission. Let's say that's something on the order of about 30 or 40% of the total amount of data and information. There's like another 60% that represents a spectrum of information, right? And our goal is to improve that 60% and bring it down in the total amount of data that isn't AI ready, make it AI ready. And that was the effort in the roadmap to very simply characterize all the different data types that exist for EM, all of the different sensors that are currently making measurements, categorize that information in certain data readiness levels. And then now that we have those categories, say, how do we take that data from a lower state of datiness ready, a datiness ready level of 1, and bring it all the way up to a data readiness level of 9, okay? And so the team is currently working quite uh, uh, efficiently, working with industrial partners that simply do that better at scale uh, uh, and faster and more efficiently with the national lab. But to do that, it really requires a certain level of partnership. One, it requires domain expertise. People who know the data, understand how it's being collected. It requires people who design agentic workflows and RAGs that allow us to um, uh, uh, characterize that information and place it in a uniform format, right? And then lastly, it requires people who can design new tools to harness that data and information and to make predictions, right? And we have people working in those kind of teams going forward as part of the Genesis mission.
That's incredible. And so with the Genesis mission, this is such like a long-term goal that is going to have both, I think, near-term outcomes, but also again some of those longer-term like solutions to those really big questions that we have. So in the short term, I know last year I talked a lot with guests about where they expect to see themselves in 2026. So as we're looking to 2027, where do you see your team and the ALTEMIS mission?
Yeah, that's a great question. So uh, we're in 2026 now. We've deployed ALTEMIS. ALTEMIS is working, uh, but the sites are still collecting 4 samples a year. And what we're currently working on is getting them down to that one verification sample. And that requires an exchange not only with DOE, but also with the state regulators who essentially regulate why we have to take the 4 samples, right? And so we're working with them so that they understand that they get the same level of detailed understanding through ALTEMIS as they would with the 4 samples that they collect. Actually, they get a little bit more understanding, right? But that requires us to do 2 things. One, educate them, demonstrate the value of ALTEMIS, right? Because it's not just cost savings; it's also recognizing that we are actually providing a safer product, right? Uh, and then lastly, making sure they understand in detail how the system works, what it's doing, and why we can go to the single verification sample. So what I would say is in 2027, we're down to simply one sample being collected for verification once a year, essentially cutting the overall cost by something on the order of 75 to almost 80% of the total cost annually.
I'm really looking forward to seeing that come out in action. And one last question before we go. You touched a little bit about partnerships, and when you talked about the state regulators, that prompted me then, this is not just something you work on with industry, it's something that you work on with the local and the state governments as well. So what is one little piece of information that you want your partners, whether on the private side or the public side, to really understand moving forward as we try to, you know, utilize AI to really get down to like the nitty gritty of our problems?
Oh, that's a great question. I think first and foremost, what I want them to always know about the national labs, and not just Savannah River National Lab, but all 17 national labs, is that we're good partners, and we're looking to uh, take the investment that DOE and the federal government is making into the laboratory to really spur innovation for the country. I think that piece is really, really important, and that's important for my industry partners and the state partners to know. Secondly, I would say uh, the sky's the limit. All right. The power of these tools is just tremendous. It's really transforming how we do science today. It's going to transform how we train students going out into the future. And that is just absolutely exciting.
We are really at a transformative moment where we have technology and we have these real world problems that need to be solved, and it's just going to take looking at that data and getting our data all lined up before we can really see some awesome action. And I know that you're seeing some good stuff right now, so I don't want to discredit that at all, because we are making some really good progress. I mean, Genesis mission was only announced in September, and I think some great strides have really been made, and I think Savannah River is really showing that. So, Eric, thank you so much for joining me today. I really appreciate it.
Thank you for having me.